are two forever cards. One is right here, it has to do with logarithms, and the other one is coming and it has to do with exponential functions. Logarithms and exponential functions. Now, hold on. Which of these right here on this card should we already know? Number one. Because that one is just a plain old simple derivative rule backwards, right?
Yeah.
Ln of x. Now, the other four are weird, and I'm not going to go through showing you every single one, but let me show you a couple. Let me show you, first of all, how to do or how to think about the integral of tangent of x dx. And then we're going to look at the integral of secant of x dx. Okay, let's start with tangent. Tangent, if we look at it, can we go with the basic rule without that forever card yet?
No.
No. We know the derivative of tangent is secant squared, but an integral goes backwards. So we can do integrals of secant squared. Give me another one.
Secant squared.
Cosecant squared, that's a derivative. What else? Cosecant, cotangent, sine, secant tangent, and then cosine. Those are the ones that we can go jump straight back. Like those are the basic trig rules backwards, okay? The basic trig derivatives backwards. Tangent is not an answer to a derivative, a basic one. So the easiest way to think about them is trig identity. He's sine over cosine. Now if I look at him like this, you sub. Who would you be?
I choose
Cosine?
The guy who's innermost, which would be the denominator. So if I made you cosine, who's du?
Negative sine x dx.
If I solve for dx, what I'm going to do right down here, dx is equal to?
du over negative sine x.
How are we doing with u sub?
good.
We're doing all right to say, hey, this is going to be negative 1 over u du? Because the signs cancel. The negative I pull out, the 1 over u, substituting for the cosine. So wouldn't this just be negative ln of absolute value of u, who is who?
Oh, that's nice.
Look at your forever card. If you ever forget the integral of tangent or cotangent, you can change them using the quotient properties and do u sub. Does that make sense? Those are kind of nice. Those are like, oh, hey, I see where it comes from. This guy, just look at the forever card. Is this guy nice looking?
No.
No, he's not as nice looking. So here's the struggle. How on earth could I get to his conclusion? Well, long story short, if I was to start from the end, the integral of secant of x is equal to ln of
Secant x plus tangent x plus secant.
Okay. Let's work backwards. This could have come out of,
1 over u.
yeah, this could have come out from the integral of 1 over u du when u is equal to,
Secant x plus tangent.
now if u is equal to secant x tangent x, question, what would du be?
du over
Right?
secant squared x dx.
Do you see how much stuff we're missing? It's a lot. It's a lot. How would we even plug in?
Give up and accept the rules back.
Kind of. Don't mind, it's not totally wrong. This would need to be divided by, right?
Yeah.
Okay. So, hold on. Who would dx be?
dx would be
Du over that. Do you guys see how there's a common secant? So dx would equal du over, I'm going to pull out that secant, and what do I have left? Tangent plus, wait, that's the same as this guy, right?
You just do it.
cosecant times u.
So if I was to rewrite this guy as secant of x times secant of x plus tangent of x all over secant of x plus tangent of x. Is that illegal if I multiply top and bottom by something?
No.
No.
Not illegal because it's just multiplying by 1, right? What would happen when we go to u sub?
plug those in you.
What I want is 1 over u, and let's see if it works. If I were just to multiply by secant x plus tangent x, I would end up with, okay, well that would be secant of x, he's not u. This would be u. Just trust me as to why I'm not making this guy a u. And then du over.
Oh, because everything cancels out.
But how nasty is that to actually show why? Why on earth would we multiply secant by this? It doesn't make any sense unless you realize the rule backwards. So this guy, I don't think you want to go forwards. That was nasty, even going backwards and forwards and kind of doing both at the same time. So why did I make it a forever? Because you just need to memorize and say, hey, if I ever got, I go straight here. And what's the other one that's similar to secant? Cosecant. What's the integral of cosecant? Super similar. ln of cosecant plus cotangent, but with a negative. Okay. Because you can think of du for cosecant plus cotangent is going to have a negative. I don't know if that helps at all, but helps a little bit maybe. Cosecant squared we know has a negative, cosecant cotangent has a negative, so maybe you can realize cosecant needs to have a negative also. Oh, P.S. Does cotangent have a negative?
Yes. No. Oh, no.
Who does have a negative? Because he has a cosine. Tangent has a u of cosine, du negative. Cotangent has a u of sine, which is going to be positive. So you got to be careful of those signs, SIG and S. Got to be careful of positive negatives. But long story short, with any integration rule, will we go faster if we have it memorized?
Yeah.
Yeah. Okay, cool kids. Some of you guys were able to practice these last night, some of you weren't. Charlie knows the struggle. Hang in there. Number 1. Let's rewrite it. 10x to the negative 1. No.
Yeah. No.
Power rule works for everything except for n equals negative 1 because look at the forever card that we just wrote down. What has an integral of 1 over x dx? Which would be the same thing as
ln, yeah, to the 10th.
wait.
It's even, so you don't have to bother about that.
Exactly. I don't need the absolute value because if I raise a positive or negative to a 10th power, they all end up positive. Does that make sense? But are they the same thing? Yes. Are they both right? Yes. That was just a basic rule. That was just a basic rule. Number 2. Who's my u?
Yeah.
The bottom. Good, good, good. So if the u is the bottom, let me go ahead and do u sub over here to save on space. 3 minus x cubed. Du is equal to? Do you guys agree? So dx is equal to?
Negative 3x squared. Yeah, okay, on bottom.
On the bottom. Good, good, good. When I go ahead and plug it in, hold on. How are we doing on u sub? We're getting faster? Can I do negative 1/3 1 over u du yet? Just in case that's a little too fast. You would plug in your u for the denominator. You would keep your x squared, you would multiply by du over negative 3x squared. The x squareds cancel, the negative 3 is a constant, but he's in the denominator, make him a 1/3.
Let's go at it.
Wait a minute, 1 over u, I don't know, u to the negative 1?
No.
If the integral of 1 over x dx is ln, what's the integral of 1 over u du? ln also. ln of u, who is who? Little guy from above.
So Misty,
Yeah,
on the AP, would they take that negative 1/3 and make that the power?
it's possible. This one, the x to the 10th is a lot more probable, but it is possible that they might do that as well, which I was going to show.
Yeah, 1/3
It's just not going to be pretty.
root.
because the third root's gonna be in the denominator because of the negative, and you have to keep your absolute value because the odd power will not resolve the absolute value. An odd root. A negative could come out of an odd root, so therefore I need that absolute value to stay. Now, for those of you guys that didn't follow exactly what we just did, look at that 1/3, that negative 1/3 in front of the ln. It can always come up as a power. But a 1/3 as a power means a cubed root, and the negative says in the denominator. Since it is an odd root, I have to keep the absolute value. So to be totally honest, Sean, I bet because of that nasty absolute value under the root, I bet they would have stopped here. But there's always a possibility.
Miss D?
Yeah.
Are there any properties of like square roots that lets you say like if you have like the square root of the cubed root of something, can you like?
Well, square root of a cubed root would be the same thing as 1/3 power to the 1/2 power, and power to power you multiply, so it'd be a 6th root. Does that make sense? Ooh, what about this guy? Start with the example for you. Who's your U? Just think inside, right? Who's your DU?
DX.
Not DX.
So what?
1/2 DX.
1/2.
Some of you are like, wait, don't I need quotient rule for that? Remember, if it's in the denominator, can't I pull out the 1/2?
Yeah.
I'm not pulling out an integral, I'm just pulling it away from the x, but isn't it way easier to take his derivative?
Yeah.
But you could have done quotient rule. Bottom d top minus top d bottom all over bottom squared. You would have gotten 1/2. So then, dx is equal to 2 du. I'm going to plug in. We're okay if I bring the 2 out and we just have secant of u du? Because the 2 and the du would have gone in, the 2 can come out as a multiplication. All right, you're still learning it. You don't necessarily have to have it memorized. If you have it memorized already, write it and be done. If you don't have it memorized, go look at it. What's the integral of secant of u?
ln absolute value of the secant of u plus tangent of u plus.
Now technically the Ferber card has an x, right?
Yeah,
But what changes when I do u instead? No big deal, just rewrite it with the u. And then who is u? Well, he's right there, so let's go ahead and plug him in. ln of secant of x over 2 plus tangent of x over 2. Guys, he's an ln, what could they do?
Oh man.
And since it's a 2, since it's an even power, can't I take away the
Yeah.
absolute value?
And you can simplify.
I mean, I guess we could FOIL it, but I'm not feeling that today.
So
We could change tangent to sine over cosine and secant to 1 over cosine and then combine it all together. If you have tangent secants and they have sines, cosines, and in the insert, you could always try t-proof and see if you can change it.
You could also just be secant x over 2. Or is that?
No, sadly, because u is all grouped together, and I need the u to go inside the secant, so that it's actually secant of. The 2 can't come out of the secant to be divided by. It was a good idea, you're like, maybe I could cancel something, right? But my problem is it's stuck in the secant, so yeah. When it's stuck in a square root, like we saw yesterday, we can like rationalize and get it out with some legal math. But when it's stuck inside a secant, there's no way to, there's no way to do that.
without taking secant inverse.
Yeah, without taking secant inverse of both sides, and we don't have another side, so let's not do that. Life gets a little bit exciting in the next one. I mean, it's already been exciting because we're using new rules, but Sean, look familiar?
Thank you, Miss D.
There's a baddie from 18.
Dirt?
Is that her? Sean?
No, the other one was a lot more juicy.
Yeah, it was a cute. It was a cute
That was
one
the
that you
older
dealt
sister.
with. But this one would still take a while. Let's just go for it. Let's just go for it. If you guys thought If you guys thought that you needed to choose a u right now from how it's written, what would you choose u to be?
X
Well,
minus
times 2.
X minus 2,
It's innermost,
right?
but it's like a,
It's the innermost, it's the one that's tracked down below. So u is equal to x minus 2.
just,
So dx is equal to du. Now, can we tell that we have some extra x's going on though?
Yes.
Okay, so what do we do when we have extra x's going on?
Solve for u.
Solve for u. So we can say x is equal to u plus 2. Okay? When we come over here, we're going to have to go ahead and plug in. Now right away I can say this denominator is u and the dx is du, but the struggle is that numerator has a lot of x's, yeah? They don't all live in Texas. So, you're welcome.
little Drake.
If I plug in, well,
You guys just don't do it. Please don't.
now, wait. We could try splitting this thing up into like different integrals, right? And we could like deal with this one and that one and that one. Or, since it's only a square, couldn't we like FOIL this all out and just get it to be one nice little polynomial? Okay, so then let's do that real quick. If I was to square u plus 2 the legal way, wouldn't I get u squared plus 4u plus 4? Don't kill Buffy. And then I have 7u plus 14 minus 3. The one Sean was doing was a cubic, so that was an adventure. So he tried splitting it up and not having to cube for a while. This one, since it's a square, it's like, okay, let's go ahead and square it. Okay. Now can't I combine some like terms?
Yes.
I have 2u squared, he's by himself. I have 8u plus 7u, 15u, yeah?
Yep.
Then I have 8 plus 14, which would be 22, minus 3, which would be 19, right? Kiddos. Can we simplify that?
Take u to -1.
We could make u to the -1 and distribute. We could do the heart method. We could do the heart method. Remember, if we have a common denominator, he just needs to go to every single term, the distribution.
Not much of a heart, is it?
It's kind of like a cloverish, like a glove, but
Like a chicken foot.
It's a love triangle.
Yeah, call it a chicken foot.
It's a love triangle.
Something. The chicken foot. That'd be a complicated love triangle. We have 3 to 1. Modern TV. Anyway, so when we divide, we get 2u, right? Plus 15 plus 19 over u. Double check. Do you guys agree? This one u's left, no u's left, and then 1 u's and they're down. Well, how do you integrate 2u?
U squared.
Yeah, u squared over 2, but the 2's cancel, right? So u squared. How do I integrate 15?
15u.
And how do I integrate 19 over u, or 19 times 1 over u?
19 times the natural log of the absolute value of u.
Oh,
Does that make sense? 19 over u, remember, is 19 times 1 over u, the new forever card. Awesome. Who is u? I've lost them. You guys have them written down.
X minus 2.
So I end up with x minus 2 squared plus 15 times x minus 2 plus 19 times ln of x minus 2. Can we just say if they wanted us to like FOIL and combine, we'd do what we have to do, but for right now, we'll just be done? Is that okay? And was that fun? Was it possible? Yeah, it just took a little longer than I wanted it to. Sean, how much harder did it get if you had a cubed, x cubed to begin with instead of a squared?
It takes a page.
It took a, yeah, and that's Sean's writing, which is nice and small and condensed. Some of you would take a lot more. Can I show you an alternate way of doing number 4? Okay, you guys have the problem, right? I need you to restate it for me in just a second. Let me get a blank page in here. What if we had the other way of solving number 4. I didn't put the number 4 like that, that's gonna be me. Okay, it's 2x squared, keep going.
Plus 7x
Plus 7x.
minus 3 over x minus 2.
Over x minus 2, yeah.
Here's a hint. With improper fractions, wait, why am I calling this an improper fraction?
Oh, could you like
Because the top is a bigger degree than the bottom.
The top is stronger than the bottom. With improper fractions inside integrals, we always want to divide? What? How do we divide
Long
polynomials?
division. Or just synthetic division.
I'm going to say polynomial division because the one that Sean had was a cubed over a squared and synthetic would not have been sufficient. I'm just going to say long division. That way we have a way that always works. Why on earth would you say polynomial division? Who goes in the box?
2x squared plus 7x minus 3.
It might not go in evenly, but guys, it's going to go in. And if it can go in, I can simplify my fraction. Think. If I had the fraction 35 over 7, is that idea more or less complicated than 5 and 2/7 if you're dealing with the idea? I'd rather know 5 and 2/7. I have 5 and a little bit, like, right, the practical application, but in math I'd rather have the 35 over 7. Same thing, they've given us the nice math form, but in reality it'd be a lot nicer to a lot easier to deal with the simplified form. So if we do polynomial division, we end up with 2x plus, well, hold on, we gotta go ahead and multiply, right? 2x times x is 2x. 2x times 2, sorry, 2x squared, lo siento, is negative 4x. It's division, so I have to subtract. I'm gonna distribute my negative and not kill any poor seals. I end up with, so easy to make a mistake there. I subtract the 2x squared and I subtract the negative 4x. How many times does x go into 11x?
11.
You guys read this problem to me, right?
Yeah.
I know it doesn't go.
Did we think
It's not nice, we have a remainder.
Was it supposed to go in evenly?
No.
You're supposed to have 0.
Oh, 19.
Maybe, am I just remembering the numbers wrong from the page before? What numbers do we have?
Well, we have 19.
We do have a 19. Do we have an 11 or a 15?
We have 15.
Yeah, 15. And 2. I don't know.
Yeah.
Spook.
No.
That's right.
Oh, actually, maybe this will turn out. Never mind. If we were to FOIL, never mind. We'll get back to it. Sorry. I remember the 15 and the 11. I got confused for a second, but we're good. So how can I, wait, that's a remainder. Oh, how do I write remainders?
Over 19 over x squared.
Exactly. So I can change this entire integral that's this nasty improper fraction to just be the integral of 2x plus 11 plus 19 over x minus 2? And the answer is, why, yes, indeed you can.
Oh.
Why is that nice?
Because the
With one polynomial division, what's the integral of 2x? 2x squared over 2? What's the integral of 11?
11 is.
What's the integral of, okay, hold on, take a second. We have 1 over x minus 2. I'm going to have to do a little baby u sub for this part, right? So u is equal to x minus 2. du is equal to, oh, it's only 1 dx. Well, that's going to be a nice one, but if it was not a 1 dx, we'd be in some trouble. So I can rewrite this as just the integral of 1 over u du. We know what that's going to be, right, guys? So I end up with my final answer of x squared plus 11x plus 19 ln of u, who is x minus 2 plus c. Wait a minute, that's totally different than the one we solved on the page before.
We didn't
Is it?
simplify it.
We didn't simplify. What's gonna happen to all the constants and the c? They're gonna get absorbed in. What's gonna happen when we do x minus 2 squared? So we get x squared, okay, we have an x squared in our answer. We're gonna get minus 4x plus 15x, we're gonna get 11x. Then we're gonna have a constant, and then we're gonna have a constant, and it's gonna get absorbed into c. Question, who's nicer, shorter, and looks neater at the end? So what am I telling you to do always with improper fractions, which you can tell because the degree of the top is higher than the degree on the bottom? Always do what first?
Divide.
Divide.
Shoot.
Life gets way easier.
Sure does.
Life gets way easier. All right, cool kids. Start with letter A. Don't stress about letter B yet. Start with letter A. What do you think? We need a U, but who is he?
Alright, let's do this.
We need a U, but who is he?
2x, I guess? I don't know. 1 plus
Who's my
square
almost
root
boy?
of x. No, that's something.
Come on, please. There you go.
I don't know, it's fun.
Honestly,
Well, I mean, we could do the 2x, but the struggle is,
Yeah, I wasn't
is
really-
it gonna help you if we have
I
1
don't
plus
know.
square root of u?
yeah, no, let's do the full thing.
Alright, well then. Your time's giving you some weird stuff to deal with, yeah? Derivative of 1 is 0. How do I take the derivative of 2x to the 1/2 power?
Well, you
You
can always
gotta-
just do
you
your,
gotta
like,
do
so
that.
square root of 2 times
Yeah, I
x
gotta
to
do
the
my
1/2.
chain rule, right? So bring down my 1/2, 2x to the negative 1/2. Don't forget your
dx.
Then dx. What's gonna happen to the 1/2 and the 2? Well, that's nice. I just canceled out. Let's rewrite it to make it easier in our brain. So we have 1 over the square root of 2x dx. So dx is equal to, I'll put that arrow in the wrong spot.
Oh, wait.
Alright, let's plug some stuff in, yeah? Isn't the whole denominator u? I gotta plug in my square root of 2x du. Uh-oh. Struggle, I got somebody extra. Oh, no big deal. What are we gonna do whenever we have somebody extra?
Solve for x.
Go back up and solve for x. Unless you go back up and say, oh, hey, look at it. Why don't I just solve for that guy? You could solve for x, but couldn't you also just solve for square root of 2x, which is who I need? Just saying, you don't always have to solve for x.
That's nice.
Yeah, it's really nice. So I just go ahead and plug in that puppy.
Oh,
So I have u minus 1 all over u.
oh, well, look
Okay,
at
now
that.
pause, no one say anything, shh. Let everybody think. That is not a basic rule right now. But I can do some math to it to simplify. Okay, now what can I do?
What's
Well,
our
you can do your part.
Part method, yeah, let's divide, let's distribute that common denominator. For those of you that might not be tracking with the heart method, what we do is we say, hey, that denominator goes with both. So I have u over u minus 1 over u. And u over u just ends up equaling 1. You okay?
Mm.
So what's the integral of 1?
You.
What's the integral of 1 over u?
It's kind of ugly.
And then we end up with 1 plus, close the end, 1 plus the square root of 2x minus ln of 1 plus the square root of 2x Technically, they could have this little 1 get absorbed into the C. The 1 could disappear and it would still be legal. You'd have another, like a new C. But I'll leave it for now. The only thing I will change is they could do hopefully most of you realize why it's 1 over in the ln, because this is a negative 1 power. But pause. How on earth was I able to get rid of the absolute value part?
Because it's positive.
1 is always going to be positive, and plus a square root. That's a positive root. That's not a negative root. So anything that comes out of a root has to be a positive number out of it. If it was a minus, I'd be in trouble. I don't know. But since it's a plus, it's always positive. We're good.
Could you always just put the absolute value bars just to be safe? But
Yeah, I
that's
just
still
don't
good.
want you to see an answer that doesn't quite match yours with absolute value bars and choose it over the one that could be exactly yours without absolute value bars. Or do like a none of these when it should have been one.
Oh, that's gonna make it.
Cool kids, what do you think? I don't think we're gonna actually solve B because I do want us to get to the other forever part. What would we do first?
Polynomial division.
Yeah, because look at this guy. You would have to do u equals x. This is the one similar to what Sean had to do. And then you could do your du equals dx. And you could say that x is equal to u plus 3. Do you see how you have to do u plus 3 cubed squared? Although we are very proud of Sean. But
We made it.
That's pretty nice.
why am I writing 0x?
Oh, because you're supposed to include that in your.
I'm just keeping it open. And remember with polynomial division, we have to keep it all nice and lined up, and whatever we choose to be our first, like this one would be x squared, I have to distribute to both, right? So I get my x cubed minus 3x squared. I'm not gonna finish it, this is where I'm gonna stop, but
Wait, hold on,
please,
wait.
please,
Go over
please,
that.
just be careful.
Go over to that. Wait, one second.
Ooh.
We can just have 0. Oh, you just bring it down, so nothing left. Okay.
Didn't that guy look so nasty a second ago? Okay, I finished the division, but what would you still have to do to finish the problem?
Well, then you.
Yeah. And you would say, oh, I can change this whole integral to be x squared plus 5 over x minus 3. Integrate them one piece at a time and you got it.
Should this is your addition. Whenever you get out of home, all of the one division and addition, so it's easy
And
to.
it could be subtraction, but either way, it's easier to take it term by term by term. It's so much easier with polynomial division. All right, we get the idea, kind of?
Yeah.
All of those tons of ln stuff. We go looking for u's and denominators, but we might have to still do some crazy integration. And then, if we see an improper, polynomial divide. What if we have, This section isn't just logarithmic, it's also exponential. Dee-doo-boo, boo-lim-boo. Dee-doo-boo, boo, limb, boo. Right? Okay, so how can I go backwards from that? That could be a du, right?
Just integrate the limbo.
So I could have the integral of
Sure.
b to the u ln of b,
You're never gonna
du.
form.
right? But the struggle is, how often do you think they give you this nice little constant
Never.
ln of b? Not very often. So if this is b to the u plus c, what if they were to give you just b to the u?
Ooh.
Oh,
Somehow
it should be.
There's gonna be
u
rules.
B to the u times 1 over b.
Like the power rule, if it's not there, it must have canceled out. Like the power rule, if the n plus 1 is not, or I should say if the n is not there, it must have canceled out. Take a second.
Are you writing that down?
Technically, we could have done something like b to the x. I just wanted to show you the u prime. We could have done b to the x, and then we could have made, what could we have
Could
made?
be dx.
Yeah. We could even technically make b to the u our u. We'd have to call it like a v or something since we already are using u. We could make b to the u our v. If you want to see it this way. dv would equal b to the u times ln of b times u prime. Then we could have solved for du. Then we could have plugged and chugged. Ooh, do I have space? Don't have a lot of space. I just want to show you how u sub, even though I'm not using u's right this second because u already has a meaning. I could have then come back to my integral and I would have had b to the u over b to the u ln of b times dv. Those b to the u's would have canceled. The 1 over ln b could have come out. The integral of 1 dv would have equaled 1 over ln of b times v plus c. Ooh, and who is v?
Something. Little something.
Little something something. Little something something. But all that, guys, are just being creative and just trying to show you why the following rule is what it is. It's just the why coming from our original derivative rule. You don't necessarily have to know the why, but if it does help you, if you ever forget and you know the derivative of b to the u, you can always find it by using a u sub. Well, I made it a v sub. But either way. Or you can just memorize your forever card really well, which you're supposed to do anyway. Aha! Hey, have you had to use the e to the u one yet?
E to the u? Yeah.
Yeah, you have. You just haven't written it down as a forever card yet.
Didn't we have it in the basic integration one?
Yeah. Oh, we did? Never mind. I'm writing it again. How come? Because I didn't want this guy to be alone. And I want you guys to remember that the same way the integral of e to the u is e to the u, the integral of b to the u is b to the u. He has that constant over ln of b. And this is, forever number, I think now 42, right?
Oh. Oh, that's because 1 over ln of e is, oh, okay.
Yeah, 1 over ln of b just cancels out. So you can use the b to the u rule for the e to the u rule. There is one little quick struggle though. We've talked about e to the u and b to the u. We've talked about ln, but who have we not talked about?
Log.
Great
log.
Straight old log, or a log base b that's not?
Is there no rule for them?
Oh, well technically there is, but what would it need to be?
There would need to be something a little nasty.
Convert it to ln
A little
first.
appreciative.
You'd have to like,
Just because b to the u has a nasty 1 over ln of b, it's the same thing with log. So if you ever had the integral of just a log base b of u. Now wait a minute, hold on, you wouldn't have that, would you? Oh, because we need to figure out in order to equal him, who is the derivative of log base b of u?
1 over...
Isn't it just 1 over u? ln of b? But hold on, what would we do, kiddos? Wouldn't we just pull out? And wouldn't we just do ln? Guess what ln of u over ln of b equals? Oh! So I don't actually need a rule for log base b of u. This is the change of base formula. Here's a quick heads up. We're always going to use ln's whenever we see 1 over u, and maybe we'll have a constant that makes it a log, but we're just going to use ln's. So it's kind of nice. We need to have a derivative rule for log base b, but we don't need to have an integral rule. Snap. All right, cool kids, you basically have enough. We're going to do a few more examples of b to the u, but you're basically done with 4-6. I would say tackle the whole homework, because there's really not much else besides a couple examples we'll do on Monday. You have all the rules. Get through as much as possible. Sound good? Woo!
Okay.
All right. Finish up this homework on Monday. You can do it.